Hey everybody, today we're going to work on Similarity 2. Now, lesson number 2, we're getting back to triangles a little bit, which is going to make you very, very sad, but that's okay. We'll get through it really quick. I like this lesson a lot. I think it makes pretty good sense once we work through it. So you can pretty much tell by the picture that these two triangles are not congruent. Back in the last semester, basically, we started working through congruent triangles. These are obviously not congruent. One of them is way bigger than the other. However, if you look, they have sort of the same shape. They're not the same size, but they have the same shape. It turns out these are similar triangles. So they are not congruent, but they are similar. So what that means, well, it means a few things. Number one, all of the corresponding angles match, and they are congruent. So, for instance, if I told you that this was 95 degrees, I'm not saying it is, I'm just sort of illustrating it for you. This would also be 95 degrees. So the sides are not congruent. The angles are. Now, the thing about the sides, they do preserve the same ratio. So what that means is the ratio of AB to DE is going to be the same as the ratio of BC to EF. So I'm just going to make up a number here. Let's say AB is 3/5 as long as DE. Then that would mean BC would be 3/5 as long as EF. It would also mean AC would be 3/5 as long as DF. It would work for everything. They preserve the same ratio. Now, the way we discuss this, we can go back to our old symbols. We could say triangle ABC. It is not congruent, like we said, but these triangles are similar. So you could say triangle ABC is similar to triangle DEF. All right. Now, in this first example, we can go back to this picture here, and we're just going to number it the way it is given to us. AB is 6, BC is 8, DF is 16.5, and EF is 12. So keep those numbers in mind. Step 1, list all pairs of congruent angles and write the statement of proportionality for the figures. So, as I said before, the angles are congruent to each other. So, angle A is congruent to angle D. And then you could say the same thing for angle B. It's going to be congruent to angle E. We don't have to get more specific than that because there's only one angle coming off of each one. So then we're going to say angle C is congruent to angle F. Okay. Write the statement of proportionality for the figures. All right, now, this is where we are going to write what's called an extended proportion. I told you about the sides earlier. It said the sides are not congruent, but they preserve the same ratio. So what that means is the ratio of AB to DE is going to be the same as the ratio of BC to EF and then that is going to be the same as the ratio of our other matching set, which would be, in this case, the longest side, which would be AC and DF. So although we don't have congruent sides, the proportions all match up. Now, the reason this is significant is because now we can use these proportions to solve for missing things. Okay, so in order to get this right, you have to find one of these fractions that you know both the numerator and the denominator of. Now, if I'm looking here, what I find is that I know the bottom side for both. Okay, I know that BC is 8, and I know that EF is 12. That ratio is going to be preserved for everything. So if I want to solve for AC, well, I don't know what AC is, so I'm just going to call it X. I could use the ratio that I already know and then combine it with one of the ratios that I don't know. So in this case, I could say 8 over 12 equals X over 16.5. And that's going to be my setup. So you take a ratio that you do know, and you combine it with a ratio that you do not know, and then you solve. Now again, I had this conversation in lesson 1. We don't really have enough time to reinvent the wheel. So if you are the kind of person that likes to cross multiply, I'm not going to tell you not to, because I'm just going to get this thing set up in no time anyway. 12x equals 16.5 times 8 is 132. Divide by 12, and x equals 11. So that means AC equals 11. All right, now, if we are going to solve for DE, we might need to scroll up a little bit just to make sure you can see. DE is right here. I'm going to call this Y. And again, we're going to take the ratio that we do know and then combine it with the ratio that we want to know. So 8 over 12, and you have to keep the same order, equals 6 over Y. Once again, whatever you're good at, however you normally solve that, that's what I would use. 8y equals 72. Divide, and you find out that y equals 9. So make sure you label it the way you are supposed to, and you say DE equals 9. Okay, so that's how we're going to do this. We're going to find a ratio that we do know, and then use it to solve for one of the ratios that we don't know. All right, now we get to the scale factor problems. Find the scale factor of triangle ABC to triangle DEF. Scale factor is just comparing the side lengths of the two triangles. And it turns out the scale factor is going to be consistent no matter what you do. Whether I choose this comparison, or this comparison, or this comparison, we already wrote our statement of proportionality. It's going to be the same no matter which one we choose. So I'm going to go with the first one. The ratio of BC to EF was 8 to 12. BC is in the first triangle. EF is in the second triangle. As long as you go in that order, you'll get it right. So the scale factor of ABC to DEF would be short, sweet, simple, 8 over 12. Now, you do have to reduce. You don't get away with that. So we're going to say 2/3, which means the side lengths of ABC are 2/3 as long as the side lengths of DEF. Now, it said find the scale factor of DEF to ABC. Now, if you didn't notice, they switched the order around. So instead of saying 8 over 12, you are now expected to say 12 over 8. which means when we reduce, we're going to have to use 3 over 2. So that means the side lengths of DEF are 3/2 the side lengths of ABC. All right, example number 2. We're going to use the diagram down below right here. And I made a little more room than you have. You can sort of squeeze in your answers in the margins or whatever you want to do. List all pairs of congruent angles and write the statement of proportionality for the figures. So now this one will be a little bit bigger. We are dealing with a parallelogram here. And so list all pairs of congruent angles. So I'm going to go in alphabetical order here on top. And I'm going to say angle R is congruent to angle L. I'm going to try to save us some time here. You're quicker at typing it than I am. You're quicker at writing it than I am at typing it. So let's just go through here, and we're just going to match up each one. R and L match, S and M match, T and N match, and U and O match. Now, as far as the side lengths are concerned, we know that they're not going to be equal, but we do know that we can make a statement of proportionality. So we could say that the length of RS is going to be proportional to the length of LM, and we could compare the proportions for each one. We could make, it's called an extended proportion. We could just keep going here. ST and MN, TU and NO, and UR or RU, whatever you want to say, it doesn't really matter, and OL. All right, find the scale factor of RSTU to LMNO. The only way we're going to get that is if we have a matching set of sides somewhere. It turns out we do. ST and MN are both given to you. And that was one of our matching sets we were looking for. Now, it said the scale factor is just whatever that is on top, ST, divided by whatever that is on bottom. And we know that's going to be the scale factor because no matter which set we choose, that number should come out to the same thing. So you just find one that has a matching set and you go with it. Now, 3 over 2.4, we don't want to write it that way. So what we're going to do, we need to change this into something simplified. If you have a calculator that does it, that's great. But what I'm going to do instead, and I actually saw some of my students already doing this, so hopefully you know, if you want to move that decimal over so that you can get something that's easier to reduce, multiply the top and the bottom by 10. And what that basically does is it fixes that decimal so that we don't have to worry about it. So instead of getting 3 over 2.4, you get 30 over 24, which would reduce short and sweet to 5 over 4. All right, now when it says find the scale factor of LMNO to RSTU, now it is in an opposite order, which means our answer should be in an opposite order. So 4 over 5. All right, next, find the length of NO. Now it is a parallelogram, which means whatever we have on one side, the opposite side should also match. So I could actually fill in right here and right here. And on the bottom figure, I could fill in 2.4. But that doesn't help me because I need the length of NO. So we're going to take one of the proportions that we do know, which in this case was the 3 and the 2.4. And we are going to use it to solve for something that we don't know. So 3 over 2.4 equals 5 over x. this will be a quick one to solve because when you cross multiply, if that's what you choose to do, you get 3x equals 12. So x equals 4. Now we want to write it correctly, so we're going to say NO equals 4. All right, find the measure of angle U. Well, we need to remember what we learned about parallelograms. If we have 125 degrees in one, we're going to have 125 degrees in the other. And we do know that consecutive sides are supplementary, so they have to add up to 180, which means angle U has to be 55 degrees. All right, find the perimeter of LMNO. So you got a couple of 2.4s, and we just figured out earlier that that's 4 and that's 4. So you add up all of those things, 4 and 4, and 2.4 and 2.4, and you should end up getting 12.8. Last but not least, find the ratio, and we're going to come up with one last interesting little tidbit of information here. Find the ratio of the perimeter of the first one to the perimeter of the second one. So you end up getting the top perimeter, which is 5 plus 5 plus 3 plus 3. And then the perimeter of the bottom figure is what we already knew, 12.8. Now, whenever you're reducing a ratio or a fraction in general, if you want to multiply by 10, that was a strategy I told you about earlier. You could fix the decimal, and you would get 160 over 128. And then if you wanted to reduce that, your calculator might do it. In this case, 32 actually goes into both of them, and you get 5 over 4, which is kind of cool because that was exactly what we got for the first. So not only are the side lengths proportional to each other, but the perimeter will also be. All right, I hope that helps get you going on this lesson. Thanks for watching. I'll see you next time.